Every system learns the same way, whether it's a human brain or a neural network. Input, process, feedback, update. That's not computer science, and that's evolution in code. When you train a model, you're doing what your neurons already do. When you debug your script, you're performing human quality assurance. The same process your mind uses to correct beliefs. Engineers build systems. Thinkers build awareness. At Quantum Edge, we merge both. We teach how machines learn, so you can master the one system that built them all, your own mind. Every learning system, biological or artificial, runs on the same architecture. Input, process, feedback, update. In AI, that translates to define, compile, fit, evaluate, predict. The engine behind it is TensorFlow, an open-source framework that turns math into intelligence. It builds computational graphs, webs of nodes and connections, just like neurons in your brain. Each node performs a calculation, passes it on, and adjusts based on feedback. That's the same process behind learning, improvement, and even consciousness. The only difference is the material. A neural network is a digital brain made of math. It has 3 layers. The input layer, where data enters. The hidden layers are where transformation happens, and the output layer, where decisions are made. Each neuron multiplies inputs by weights, adds a bias, and runs the result through an activation function. The equation looks simple, but that one line describes all of modern AI, from chatbots to image generation. Example, you feed a sentence into a model. This film is amazing. The hidden layers analyze tone, context, and emotion. The output layer predicts positive sentiment, 0.9 confidence. The deeper the layers, the more abstract the understanding becomes. Just like your brain, from raw sensory input to emotional meaning. Every network learns through 2 motions, forward and backward. In the forward pass, data flows from input to output. The network makes a prediction. Then it measures error, the difference between predicted and true output. That's the loss function. Using backpropagation, the system sends that error backward, adjusting each weight that contributed to the mistake. Repeat this thousands of times, and the network starts predicting with precision. In the human brain, it's the same principle. Every failure sends feedback through reflection. Machines call it training. Humans call it learning. Without activation functions, neural networks would be blind. They'd process information linearly, like spreadsheets, not minds. Activation functions introduce complexity, the spark of nonlinearity. These functions decide which neurons fire and which stay silent. In biology, that's emotion. In AI, that's activation. Both determine what the system pays attention to. Traditional networks forget. They see each input as new isolated data. But language has memory. The meaning of one word depends on what came before. That's why we built recurrent neural networks. They loop information from one step to the next, creating sequence awareness. But early they had short-term memory loss. The signal faded over time, so we evolved the architecture. Long short-term memory networks and gated recurrent units. They add gates, mechanisms that decide what to keep and what to forget. Like your own mind filtering which memories matter. Machines can't understand words and only numbers, so we teach them language through tokenization and embeddings. Each token becomes a numerical vector in a high-dimensional space. Words that share meaning cluster together, logic near reason, emotion near feeling. That's semantic geometry, always meaning represented as distance. Your brain does something similar. It groups related thoughts through association. AI just learned to map it in math. Then came the revolution. Transformers. They changed how machines read. Instead of scanning word by word like recurrent neural networks, they see the entire sentence at once. The secret is self-attention. Each word becomes aware of every other word and learns which ones matter most. That's not just code. That's focus and mathematically defined. The same process your brain uses when it tunes out noise to find meaning. On the cloud, Vertex AI turns all this theory into a scalable ecosystem. It handles the entire pipeline: data preparation, model training, evaluation, deployment, monitoring, AutoML for simplicity, custom training for control. It's not just automation, it's evolution at scale. AI systems now build, test, and deploy other systems, a recursive loop of intelligence training itself. Here's the truth. Machines don't learn differently from us. They just do it faster. When a neural network adjusts its weights, it's rewriting belief. When you reflect on an experience, you're doing the same. The system doesn't care whether it's silicon or synapse. It only knows one law. Feedback creates evolution. AI learns from data. Humans learn from meaning. But both follow the same blueprint, the search for a more accurate model of reality. The deeper we study machines, the more we uncover about ourselves. Because every algorithm is a mirror. At Quantum Edge, we don't just study AI. We study awareness, the system behind all systems. Subscribe if you're ready to learn both. How machines think, and how to think like a machine without losing what makes you human. This isn't motivation, this is mental engineering. Welcome to Quantum Edge.